So you've probably heard about Amazon EKS, right? It promises to give you all the incredible power of Kubernetes, but without all the headaches. But how does it actually work? Well, over the next few minutes, we're going to pull back the curtain and break down its core architecture, piece by piece.
Okay, let's just start with the big question right out of the gate. We all know Kubernetes is amazing, but let's be honest, managing it yourself can be a total nightmare. You're talking about patching, scaling, securing the control plane. It's a huge operational lift. So what if you could get all those amazing benefits without that soul-crushing work? Well, that right there is the entire promise of Amazon's Elastic Kubernetes Service, or EKS. It's designed to handle all that complex, messy infrastructure management so you can focus on the thing that actually matters, building and running your applications. So let's get to it and look under the hood. To really get a grip on how EKS is put together, I want you to imagine we're building a highly automated, super modern city. And like any good city, it all starts with a blueprint, one that's divided into two very distinct districts that have to work together perfectly. So, in our city, you've got two main areas. First, there's City Hall. This is the control plane, the absolute brains of the operation. It's making all the decisions and managing everything. And the best part? AWS runs this for you completely. Then you have the rest of the city, the skyscrapers, the factories, all the places where the real work happens. That's the data plane. It's the brawn, and it's where your applications actually run. This is the part you manage. Okay, so if the data plane is our sprawling city, the first thing we need to do is decide what kind of buildings we're going to construct. In the world of EKS, these buildings are our compute resources, the actual servers where our application containers are going to live. And the most fundamental building block here is what we call a Kubernetes node. It's pretty simple, really. In EKS, a node is just that basic unit of compute power. You can think of it as an EC2 instance or even a serverless environment with Fargate. That's where Kubernetes will schedule your application pods to run. Now, right away, you have a really important choice to make. You can go with managed node groups. Think of this like AWS acting as your building supervisor. They handle all the maintenance, the patching, the upgrades, the health checks, the whole shebang. Or you can choose self-managed nodes. Here, you're the architect, the construction crew, and the building manager. You get total control, but you're also on the hook for everything, from the OS right down to the bootstrap scripts.
And this little table here really makes the choice crystal clear. For most general-purpose stuff, managed nodes are going to be your best friend. Super low overhead, lots of automation. But hey, if you need a really specific custom operating system or some heavy-duty hardware like GPUs, then you'll want the fine-grained control of self-managed nodes. And then there's Fargate. If you're running microservices or little jobs and you just don't want to think about servers at all, Fargate is perfect. We're talking zero management overhead.
All right, our city has buildings, but a city with no roads, no power grid, no internet cables, well, that's not much of a city, is it? We need to connect everything. In EKS, this is our networking layer, and honestly, it's one of the most critical parts of the whole setup. The magic behind EKS networking is something called the Amazon VPC CNI plugin. And what it does is deceptively simple but incredibly powerful. It gives every single one of your pods its own real, unique IP address directly from your cloud network, your VPC. It's just like every apartment in your city getting its own official street address, not just some internal mailbox number. So you might be wondering, how does that actually happen? It's a really elegant little dance. First, the CNI plugin attaches these virtual network cards, called ENIs, to each node. Then, each of those ENIs gets preloaded with a whole pool of secondary IP addresses. So when a new pod needs to start up, boom, it just gets assigned an available IP from that pool. It's clean, it's fast, and it's deeply integrated into the AWS network.
And the payoff for doing it this way? Oh, it's huge. Because pods have real VPC IPs, you get better performance and lower network latency. You can apply standard AWS security groups directly to your pods for super granular security. And all your traffic just shows up in your VPC flow logs, which makes debugging 1,000 times easier.
Okay, but there's always a catch, right? And with the VPC CNI, it's a big one you need to plan for. You can run out of IP addresses. Since every single pod is taking up a real IP from your network, you have to be really careful when you plan your VPC's address space. Seriously, your initial network design is one of the most important, long-term decisions you'll make when you start with EKS. So our city's built, it's all wired up. Now we got to talk about security. We need locks on the doors, key cards for the employees, and guards at the gate to enforce the rules. In EKS, this security model boils down to a core AWS service you probably already know, IAM.
So let me ask you this, because it's a classic security problem we all face. Your application, running inside a pod, needs to do something like read a file from an S3 bucket. How do you give it permission to do that without doing something dangerous, like hard-coding secret keys in your container? That's a huge security no-no.
The modern, secure, and frankly, the only way you should be doing this in EKS is with something called IAM roles for service accounts, or IRSA for short. It's this brilliant mechanism that lets you link an AWS IAM role directly to a Kubernetes service account. Basically, you're granting AWS permissions based on the pod's identity inside the cluster.
And the way it works, well, it feels like magic, but it's really just brilliant engineering. First, you link those two identities, the Kubernetes service account and the AWS IAM role. Then, when your pod starts up, it gets a special token. The AWS code inside your pod shows that token to AWS, which checks it, says, yep, you're legit, and then hands back temporary, short-lived security credentials. No static keys ever touch your pod.
So why is this such a big deal? Well, first, and this is huge, you completely eliminate long-lived, static AWS credentials from your applications. It also means you can enforce the principle of least privilege at a super granular per-pod level. This has become the absolute gold standard for giving your EKS apps secure access to things like S3, DynamoDB, or any other AWS service.
Okay, we have spent a ton of time walking through our city, the data plane, which, remember, is the part you manage. Now let's take a quick peek behind the curtain at City Hall, the control plane, to really appreciate everything AWS is handling for us.
You know, there's a phrase that really gets to the heart of EKS, and it's this. EKS is all about managing the complex operations so that you can focus on your applications. That's the whole point. It abstracts away all that tough infrastructure work so your teams can focus on building great software, not babysitting a Kubernetes cluster.
And what does that actually mean for you day to day? It means AWS is on the hook 24/7 for keeping the API server highly available and patched. They manage the mission-critical etcd database with automated backups and monitoring across multiple AZs. They run the scheduler that intelligently places your pods and the controller managers that make sure your cluster is always in the state you want it to be. This is a massive operational burden, just gone.
So when you put it all together, the managed City Hall, the flexible buildings, the native citywide networking, and the integrated security system, what you get is this incredibly robust, secure, and automated foundation on which you can build your entire application city.
Look, at the end of the day, EKS is designed to handle all that heavy lifting for you. The architectural complexity, the infrastructure, the security plumbing, and all that operational toil. It gives you a stable, scalable platform that's ready to go from day one. Which really leaves us with the most exciting question of all. What will you build on top of it?